This is the first in my IoT DIY kind of tutorial, so you can see what I'm thinking about when I'm designing these things and what goes through my head. Hopefully this will help you to make better projects that will run 24/7, because that is my goal. I don't need something that just runs for half a day and crashes. That doesn't work with me. So as you can tell, I got an Arduino Nano here with an ENC 28J60, I think, Ethernet shield, a very reliable unit. I've had this one running for 2 years outdoors and it worked without a hitch. Might include a little video somewhere up there for you to check out. Two of the ESP01s, one with a relay, one with the DHT22 humidity and temperature sensor, and a 8266, I believe, and an Arduino Uno with an Ethernet shield, which is also very stable in my testing. Now these are just your cheap clones, which I'm more than happy to use when I'm doing tests. However, when deploying something out there in the wild that I actually want to last, I recommend this company, Elegoo. This is not sponsored by any stretch of the imagination. However, I do think that their products are good quality, so I use them for like proper deployment. And this is a RS485 Modbus shield, which is also really cool. But Keenies, I can never pronounce the name of this company, but also really good. I highly enjoy it and recommend both of them. They make good stuff. Now the second thing that's important will be to power your projects. So if it's like an Arduino Uno or the Nano, I use something called the passive power over Ethernet, I think that's the one. So as you can tell, this is where your wire is, the long distance. Obviously it's short for this demonstration purposes. You plug in one end to the, wrong one. I'll just use this one. Where is it? Which way around? Here we go. Plug this in. This would go into the barrel. I know it's a wrong ending connector, but I couldn't find anything more useful. And this bit will go to your switch at your center hub, whatever that might be, and this will be your 2.1mm barrel. This is where the power will come in, and it will power the unit this way. So we can deploy this quite far away. I've used this again in my 2-year outdoor test project, and it worked just fine. No glitches, no issues whatsoever. Now, when it comes to delivering power, let me just move these out of the way for a second for you. I like to maybe go with an overkill. I use a UPS, and it's just a big battery that's you can connect stuff to, but it's whenever you have a power cut or a surge, it protects all of your stuff. And I found in my testing that a reliable power source, it makes all the difference in the world. So it's just my thing. It's like when I deploy normal servers anywhere, I also have a UPS. There's a no start, there is no UPS gonna happen. It's like, what, 100 quid, and it saves you so much hassle, especially with these small guys and troubleshooting. Trust me, it's just worth it. Get a UPS if you're actually planning to deploy something, and one UPS can power up 15, 20 of these little bad boys, so it's not a big deal. Probably more, but obviously depends on what size UPS you get. Now the other thing I also need to mention, that with especially the Arduinos, they have things called the reset pins, so you can actually connect them to a pin and connect that to a reset, and I think it's a very good feature to reset your Arduino that way with a watchdog when it all goes pear-shaped, and I will show now a video that demonstrates this. Pay close attention to the difference between the soft reset and the hardware reset when there is a wire in the Arduino. It resets the entire board, but yeah, here it goes. Watch now. Keep a close eye on the difference between a soft reset and a more hardware reset. So first goes the soft. Look at the LEDs. Not much changed. Yeah, it's kind of a response. Now a hard reset. This resets the entire board because the pin is connected to the actual reset pin. So it's much better in my opinion. Watch again. Boom. All of it just gets resetted, which I think is so much better. Hopefully that clears it out for you. And the next thing I'll be talking about are the board for these guys, the Arduino Uno and Nano. And what it basically does, it's detecting a brownout and protecting the circuit from damaging or memory getting corrupted, EEPROM, etc., etc. You can doodle that on your own if you want to have like a better understanding of what actually it is and what that entails. But for the purposes of this video, that's all you really need to know. I think these two by default have a setting of 2.7 volts, and you can change it to 4.3 or 4. I might be wrong on that one, but I think that's what it is. So yeah, there is that. So that's also very useful if you're running your projects 24/7 like I do. So the next thing will be a very important feature, exists on both of them. It's the watchdog. It's just this godsend really. What it does, there's basically a separate circuit of sorts. I'm not sure exactly where is it on the board. I'm sure Google can help you with that. And the longest setting is 8 seconds. So the circuit runs and runs. When it reaches 8 seconds and the time is not being reset by the actual controller, it will restart the entire unit. Now, which is amazing because it means that if your software, hangs or crashes, gets an unexpected error of sorts, and it does because it's just software, nothing's perfect, and it'll just restart it. So I think that's amazing. And yeah, I think that's all I had to say to cover the topic of getting hardware in that will work 24/7 for any of the projects you might have. Now, I will include down there, if I can point the right direction, some of the blogs, especially with the brownout, that include some videos of the test I've done with a actual voltage regulator, a little tiny cheap one, so you can see what happens when certain voltage is at certain levels and what the board does. I think I've done most of the tests on an Arduino Uno, but same applies to the Nano, so you will get the general gist, what to expect. And yeah, just a short recap. Make sure you have quality components when deploying them in live, like in your home for your automation stuff. You have good power supply, like a UPS. Power over Ethernet, yeah, that can also be included. Set up the reset on your Arduinos. The brownout is another one, super cool. And obviously the watchdog, which is like, yeah, godsend, as I already mentioned. These, I don't think they have the relevant features as these two. Could be wrong, but last time I checked this one when I was working with this, it's a rather simple microcontroller, very useful though, but limited in functionality. The next the next video, not set, will be about creating a software framework to control them all using the same commands, and they will respond the same way, so it's easier to manage them, because that's the next thing in IoT. How do you manage 20, 30, I don't know, 1,000 devices on your network, or just scattered around places? But yeah, I think I'm starting to ramble and my voice is slowly going, so I think I'll finish. Thanks for watching. Cheers.